The question we are solving now belongs to test series 10. It is of network theory subject. In specific, it belongs to DC network solution methodology. Please note that this is a linked answer question. As per the question, there is a DC network given as shown. It contains a 2 volts voltage source in series with a 5 ohm resistor. And this series combination is in parallel with a 1 ohm resistor, in parallel with which there is a dependent current source which carries a current of V1 by 10, and the drop across the 1 ohm resistor is V1. Across the terminals of the current source there is a resistor RL which is variable. We need to find the value of RL for maximum power transfer. For finding the RL for maximum power transfer, we need to, as the circuit contains the both independent and dependent sources, for maximum power transfer, load resistance RL is equal to Thevenin's resistance, and which can further be written as open circuit voltage between the terminals A and B and the short circuit current between the terminals A and B. So we need to find each of these two values, hence we will get RTH. From this we can get RL. First, let us find out the open circuit voltage between terminals A and B. So for finding the open circuit voltage, let us draw the equivalent circuit as shown. And in this case, the terminals A and B should be left open. So the potential at the point is V1. So upon applying nodal analysis, we see that V1 minus 2 divided by 5 plus V1 divided by 1 minus V1 divided by 10 is equal to 0. And this can further be simplified as V1 multiplied by 1 plus 1 by 5 minus 1 by 10 is equal to 2 by 5. This can further be simplified as V1 multiplied by 11 divided by 10 is equal to 2 by 5. That implies V1 is equal to 4 by 11 volts, which is equal to the open circuit voltage between the terminals A and B. Now we got the numerator. Now we need to get the denominator, which is the short circuit current between the terminals A and B. For finding the short circuit current between terminals A and B, let us draw the equivalent circuit as shown. Please note that in this case, the terminals A and B should be shorted. As the terminals A and B are shorted, the potential at the point marked is equal to 0, so V1 is equal to 0 volts. As V1 is equal to 0 volts, the dependent current source carries a current of 0 ampere. Hence, the current through the 5 ohm resistor, which is I1, can be written as I1 is equal to 2 minus 0 divided by 5, that is equal to 2 by 5 ampere. From this, we can say that the short circuit current ISHAB is equal to I1 plus V1 by 10 plus V1 by 1 or minus V1 by 1. This is by KCL. As V1 is equal to 0, this quantity is equal to 0 and this quantity is equal to 0. Hence ISHAB boils down to I1, which is equal to 2 by 5 ampere. Hence we got the quantity which corresponds to the denominator as well. From this we can find the RL for maximum power transfer as RL is equal to RTH is equal to VOCAB divided by ISHAB, that is equal to 4 by 11 divided by 2 by 5. And upon simplifying this, we get this as 10 by 11 ohms. Hence the correct option which corresponds to the value of RL for maximum power transfer is B.